Assalamu alaikum. Dear class 10 English version science students. Today I will discuss about current electricity. It's 11th chapter. In fact, is the topic picture of this chapter. Okay. Today our chapter name is current electricity. Dear students, nowadays we can't spend a single moment properly without electricity. To operate machine and other instrument and us, we need electricity. In the previous chapter, we discussed static electricity. Dear students, when charge flows through a conductor, we call it current electricity or in brief, electricity. We will describe the terms required to explain current electricity and learn the rules of flow of electricity. In this chapter, we will also discuss how we can measure electricity in a circuit. Moreover, we will measure potential difference. Dear students, by the end of the chapter, you will be able to demonstrate the production of current electricity from static electricity. You can demonstrate the production of a current electricity. You can explain the direction of electric current and flow of electrons. Okay, you can explain direction. You can draw a circuit by using the symbols of electric devices and appliances. You can explain conductors, insulators, and semiconductors. Dear students, you can establish a relationship between electric current and potential difference by using a graph. Okay. You can explain, dear students, fixed resistance and variable resistance. You can explain electromotive force and potential difference. Dear students, you can explain dependence of resistance in our daily life. You can explain resistivity and conductivity. You will use series and parallel resistance. Okay, we will use series and parallel resistance. My dear students, you will use equivalent resistance in a circuit. Okay, equivalent resistance. You will calculate electric power in a circuit. That means you will calculate electric power in a circuit. You can explain system loss and load shedding in circuit or daily life. You can describe the safe and effective use of electricity. You can explain safe and effective use of electricity. You can draw a typical house circuit and demonstrate the use of AC source in its different parts. You can draw a poster to build consciousness about dissipation and conservation of electricity. My dear students, first we want to discuss about from the beginning. Okay, what is matter? Actually, matter, if you look at your room, if you look at your surroundings, you can see different things. Okay, in your room you can see table, chair, laptop, television, or you can see the wire of electricity. You can see electric wire. Okay, it's made of copper. What is matter? Okay, at first you have to understand. These are matter. Okay, the copper wire, fan, this ceiling, table, chair. These are matter in your room. If you go outside, you can see different type of matter. Okay. Look here. You can see a chair. Okay. You can see glass. These are matter. Okay. These are made of glass is made of glassware made of glass, and chair is made of wood. So these are matter. But dear students, This is iron metal and copper metal. Iron metal and copper metal. Now you can ask what makes a metal? What makes a metal? This question may be arisen in your mind. Okay. This is water metal. Water consists of oxygen atom and hydrogen atom. Okay, oxygen atom and hydrogen atom. And copper metal consists of copper atom. Iron metal consists of iron atom. Okay. Now come to the main point. Copper metal. Copper consists of copper atom. That's why what makes up atom? Now this question may be arisen in your mind. What makes up atom? Proton, electron, neutron. Okay, proton, electron, neutron make the atom. Now look at this picture. You can see an atom of argon. Electron fills up on orbit than other orbits. That means I wanna show you a construction of atom. Okay, atom consists of electron, proton, and nucleus. Nucleus, proton, and neutron stay in nucleus, but electron stays in orbit, in different orbit. It's an example of argon atom. Electrons fills up on orbit and then other orbits. Now, what are the properties of proton, electron, and neutron? That means you have to know the properties of proton, electron, and neutron. Proton is positive charge carrier. Proton is a positive charge carrier. Do you know where does it stay? It stays at the center of atom. Do you know the amount of charge of proton? It's positive 1.6 into 10 to the minus 19 coulomb. Positive 1.6 into 10 to the minus 19 coulomb, the charge amount of proton. Now, electron is negative charge. What type of charge electron? Negative charge carrier. It stays at different orbit of atom. Its charge amount is minus 1.6 into 10 to the minus 19 coulomb. It's a charge, okay? 1.6 into 10 to the 19 coulomb. Now, you have to understand the free electron. What is free electron? Free electron, electron in outermost cell of an atom, on which the attractive force of the nucleus is very small and which can be removed very easily from the parent atom is called free electron. That means there are some electrons at the outermost cell and there are less amount of attractive force between those electron and nucleus. Okay, that's why those type of electron can be removed very easily from the parent atom. Okay, those are free electron. Okay, free electron stay at the outermost cell of an atom. Free electron picture you can observe free electron, the metal atom, red side metal atom, and pink sign free electron. These are free electron. Okay. In this way, free electron electrons move in the matter. Okay. Now why we have to know about electron and proton? That means this question may be arisen in your mind. What the necessity of learning about electron and proton? What's the necessity? Okay, why you will know? Because you can understand the necessity from this definition. the definition of electric charge. Definition of electric charge. What's the definition of electric charge? Means electron and proton is an intrinsic characteristics of the fundamental particles. Intrinsic characteristics of fundamental particles, whose presence generates static electric field and static electric charge in an object, which can attract very tiny objects like a small piece of paper, and due to their motion, electric current, electric field and magnetic field are generated. Okay, that means intrinsic characteristics, electric charge. Here, their electron and proton are firmly related to this definition. Now, my dear students, you look at this picture. You can see during winter combing here, and if the comb is held near the piece of paper, they feel attraction. Okay, they feel attraction. From above picture, what can we say, or what can we ask from above picture? We can answer, what is electricity? What is electricity? Electricity is a form of energy due to friction, the invisible energy generated in a body that can attract light object like small piece of paper is called electricity. It can be converted into other forms of energy. You have understood what is electricity. Electricity is a form of energy. Now, how many types of electricity? That's why this question may be arisen in your mind. How many types of electricity? There are two types of electricity, dear students. There are two types of electricity. One is static electricity and is current electricity. Okay. Now, what is static electricity? What is static electricity? Static is when charge or electricity is confined in an object. That means it doesn't move from one place to another place. Then it is called static electricity. Let me show you an example. Here, static electricity. When you comb your hair, you can see that comb attracts a small piece of paper. Okay, is the example of static electricity. Now, my dear students, what is called current electricity? What is called current electricity? Current electricity, when electricity does not confine in a body, that means it moves from one place to another, then it is called current electricity. Okay, I am sure you have understood what is current electricity, what is static electricity, and let me show you two examples. This is current electricity. You look at this animation, you may understand properly what is current electricity. You can see the movement of electron. Okay, they are moving one place to another place. They are not at rest state. Okay, that's why it is current electricity. Let me show you another example. Here, bulb is lighting. Why? This for the movement of electron, the bulb is lighting. It's a current electricity because electron charge is not at rest. It is in motion. That's why it's current electricity. Okay, let me show you another quantity, electric current. Electric current. The amount of charge following per second in a particular direction and the normal to the cross-sectional area of a conductor is called electric current. Simply you can say flow of charge in unit time along any point of the conductor is called electric current. I'm sure you have understood what is electric current, amount of charge, okay, following per second. Now, my dear students, you can see from this animation and you can understand what is electric current. What is electric current? You can see from this animation, red sign animation, okay. Here, red sign animation, okay. These are positive charge movement, and passing q amount charge through this area, okay, per unit time, through this area A per unit. And if we consider the electron, then we can see the direction of current along this way, okay. This blue sign means electron falling, okay. This is the direction of electron falling. Actually, that is positive charge movement direction is old rule of the direction of current, and this is the new method of direction of electricity or current, that means falling of electron. Anyway, but this is acceptable, okay. First convention is acceptable, that means along this direction current is falling, so we have to think about this, okay. Now, my students, electric current I equal to Q divided T. Q means charge, T means time, and electric current unit is ampere, in short form A. Okay, you have to remember this formula, I equal to Q divided T. If you get the amount of Q and time, you will find out the current, electric current. Okay. Now, my dear students, how can electric current flow? This question may be arising in your mind. How can electric current flow? In fact, we have discussed in previous chapter that if two bodies have a potential difference, then charge flows from the body of higher potential to the body of lower potential. The flow of charges continues until the potential becomes equal. Okay, this flow of charge is the flow of current electricity, which we generally call electricity. Using this electricity, lights run on fan rotors and phone charges. Okay. Now, electric potential. Amount of work done in bringing a unit charge from infinity to a point in an electric field is called electric potential at that point. Electric potential is denoted by B in this volt. Potential B equal to W divided Q. Here W is amount of work and Q is charge. Okay. You have to remember this formula, then you can find out voltage or potential if you know the work done amount and charge amount. Okay, dear students, now look at this picture. You can see A square, B square. Okay, and you can see where these two square are connected. Okay, by this wire you can see. And moreover, you can see A square is charged, positive, positive, positive. B is chargeless. That means there is no charge. If we connect if we connect A and B by a wire, you can see charge will flow to B. Here, A square charge space higher potential. This is lower potential. For the difference of potential, charge goes from A to B, and until the charge that means potential difference equal, charges movement is happened. Okay. Look at this picture. You can see the amount of charge A square 1, 2, 3, 4, 5, 6. The amount of charge 1, 2, 3, 4. That means we can say the potential of A and B same. That's why then no charge flow, no charge flow from A to B. Okay, that means you have understood that charge flows due to the potential difference. Okay, if you understand potential difference, then you can understand electricity flows from a charged sphere to an uncharged sphere. Now, homework. Just you think about potential difference, electromotive force, battery. That means you have to differentiate the potential difference, electromotive force, or potential or electromotive force, and you have to understand battery cell. Okay. Moreover, you have to understand or to think to read from a book conductor, non-conductor, and semiconductor. Okay. Moreover, you have to understand electric circuit. You have to understand what is resistance. You will find out the meaning of resistance and electric circuit from your book. Thanks a lot, my dear students. Stay safe and secure at home. Okay. Best of luck. That's all today. See you next lecture.